In this video, we are going to learn about 3.3 electrolytic cell. At the end of this lesson, students should be able to explain the influence of the following factors on the selective discharge of a species at the electrode: standard reduction potential, concentration, and inert electrodes, and predict the electrolysis of the following electrolytes using inert electrodes: molten salt, concentrated and dilute aqueous NaCl, aqueous Na2SO4. Last but not least, predict the products of electrolysis using appropriate examples. Selective discharge and electrolysis. Cations are discharged or reduced at cathode, while anions are discharged or oxidized at the anode. Species discharge are selected based on standard electrode potential or their position in the electrochemical series, concentration of the species, and type of electrode. In this video, we will focus only on inert electrode. The first factor is standard reduction potential. Cation, which is discharged at the cathode, must have more positive standard reduction potential, SRP. Anion, which is discharged at the anode, must have more negative SRP. Common ozoanions such as sulphate, carbonate, nitrate, and phosphate, also F-, are not oxidized because the central atom is already at its highest oxidation state. So, if you encounter these common ozoanions, you can just ignore them because they will not be selected. Let's see example for an electrolysis of molten salt. In electrolysis of molten salt, only ions from the salt are present. For example, molten NaCl. The species present in the electrolytes are Na+ and Cl-. Na+, a cation, will be attracted to the cathode and undergo reduction. Cl- and anion will be attracted to the anode and undergo oxidation. The reactions at the electrodes are as follows. At anode, 2Cl- will be oxidized into Cl2 gas and release 2 electrons, while at cathode, 2Na+ will gain 2 electrons and produce 2 Na. Overall, 2Na+ plus 2Cl- will produce 2Na plus Cl2 gas. Please make some correction at the phase of Na. It is solid, not liquid. Thank you. The product form is chlorine gas at anode and solid sodium metal at cathode. And the observation is bubble gas produced at anode representing the chlorine gas, and the cathode becomes thicker when the sodium metal is deposited. Now, let's look at the electrolysis of diluted aqueous salt solution. In electrolysis of aqueous solution, there are water molecules instead of ions from the salt. Instead of anion from the salt, water molecules will also attracted to anode. Instead of cation from the salt, water molecules will also attracted to cathode. This diagram shows the electrolysis of diluted NaCl. A diluted solution contains water molecules. So in this electrolysis, water molecules will be extracted to cathode and anode. Species extracted to cathode is Na plus and H2O. To select which species will be reduced, we will look at their SRP values. For Na+, the value is negative 2.71, and for water, it is negative 0.83 volt. As we have mentioned before, the species selected at cathode must have the more positive value, which is, in this case, it is water molecules. So water molecules are reduced in preference to Na+, because its standard reduction potential is more positive. Hence, the equation at cathode is 2H2O liquid gain 2 electron and reduce into hydrogen gas and 2OH minus. While the species attracted to anode is Cl minus and H2O. Again, we will look at their SRP values. For Cl, the value is positive 1.36, and for water, it is positive 1.23. Please note here that the equation and anode values for water is different for cathode and anode. Make sure you select the correct equation and anode values for water. By comparing these values, we know that we must select the species with more negative SRP values. In this case, it is water. Hence, H2O is oxidized in preference to Cl minus because its standard reduction potential is more negative. So, the equation at anode is 2H2O liquid oxidized into oxygen gas plus 4H plus and 4 electrons. So, we can rewrite the half-cell equation at cathode and anode as follows, and then the overall cell reactions will get 2H2O liquid produce 2H2 gas plus oxygen gas. The product and observation will be at cathode, bubble gas produced indicating hydrogen gas, and at anode, bubble gas is also produced indicating oxygen gas. The second factor that affects the selective discharge is concentration. For example, we have the following electrolysis of concentrated aqueous salt solution NaCl. As the same for aqueous solution, the species present in the electrolytes are the salt Cl minus, Na+, and water. Species attracted to cathode are Na+ and H2O. We will refer to the standard reduction potential, and from these values, we can see that there is a huge difference between the SRP for Na+ and H2O, a very huge difference. This means that concentration does not have effect. Therefore, water molecules are selected to discharge in preference to Na+ because its standard reduction potential is more positive. Please remember here, if there is a huge difference, concentration does not have an effect, we will refer to the more positive SRP. The equation at cathode will be 2H2O liquid plus 2 electron produce H2 gas and 2OH minus. Next, the species attracted to anode are Cl minus and H2O. By referring to their unit values, there is no much difference between positive 1.36 and positive 1.23. The gap is so small that the concentration does have an effect, which means the Cl minus is oxidized. It is selected to oxidize in preference to water because of its higher concentration. So, if the difference in inert cell is small, we will select the ions from the salt because of the higher concentration. Thus, the reaction at anode will become 2Cl minus oxidized into Cl2 gas plus 2 electron. The half cell reactions and the overall cell reactions are as follows. Can you predict what is the observation and the products? Well, by looking at the equations, we know that Cl2 is produced at anode, so the observation must be bubble gas produced, and at cathode, bubble gas is also produced, representing the hydrogen gas. Last but not least, we will look at the example for electrolysis of aqueous sodium sulphate. The diagram is as follows. In the electrolytes, the species present are SO4 2 minus, Na plus and water. At cathode, they are Na plus and water, and as usual, by referring to their SRP values, water is selected to discharge because the SRP is more positive than Na plus. While at anode, the species are SO4 2 minus and water. As we have mentioned before, if you encounter common azo anions such as SO4 2 minus, we can ignore them because it cannot be oxidized because the sulfur atom is already at its highest oxidation state. Therefore, at anode, water will be selected to discharge. Now, we combine both half-cell equation at cathode and anode, and we will get the overall equation as 2H2O gas produce 2 hydrogen gas and oxygen gas. The product and observation will be as follows. At cathode, bubble gas is released, representing the hydrogen gas, and at anode, bubble gas is also released, representing oxygen gas. That's all for this video. Thank you.